Okay, general purpose input output GPIO we will see. So the purpose of this lecture is mainly giving some more basics about GPIO and GPIO configuration. So how can we configure GPIO in push-pull mode and open drain mode? So what is push-pull and what is open drain? We will see that. So let us start now. So we know microcontroller have several input output pins. So each pin we can configure according to what we want, what function we want to obtain from the pin. So we can configure the pin in IO pin, that is the input output pin. Just a minute, I will take the pen. So this input output pin you can configure in different modes. For example, you can configure in output open drain mode and push pull mode. Both are in output mode. And similarly, you can also configure the pin in input mode. So it means the microcontroller will receive the input through that pin. So you can configure as a input floating mode or input pull up mode or input pull down mode. So there are three possible modes you can configure the input pin. And similarly, we have analog. So you can also configure the pin for analog purpose. So in this case, for example, when you use the ADC or DAC, that is the analog to digital or digital to analog conversion, you can use this pin. You can apply the analog signal. Then microcontroller has all the inbuilt blocks. So for example, microcontroller has its own ADC, analog to digital converter. So when you apply the analog signal, then it will convert in terms of digital to process by the CPU, because CPU can, or the main core can only process the signal in terms of binary data, zeros and ones. And similarly, we can also configure the input output pins with some alternate functions, like alternate function input output. So this is for mainly for peripherals, to use the peripherals. There are so many different peripherals available in microcontroller. So we had seen different peripherals in the last or the week before last week lecture. So for example, the timer UART. UART means universal asynchronous receiver transmitter. So there are so many peripherals available. So you can also use the pin. You can configure the pin to utilize the function of these peripherals. And similarly, you can these all are like you can also configure in terms of AF open drain or AF push pull mode. So you should understand what is this open drain and what is this push pull mode. Of course, everything is happening inside the microcontroller, but it will be interesting for you to understand the concept of this open drain and push pull mode. And inside the chip, we are not only depending upon single high voltage level. Nowadays, we have the multi voltage system actually inside the microcontroller. So the high voltage, I mentioned here, the high voltage is this VDD. It doesn't need to be only plus 5 volt. It can be dual voltages. It can be plus 5 or it can be plus 3.3, or it can be any other voltages based on the system designer who is writing this program. Okay. So here in this microcontroller, now we are only after this STM32 microcontrollers. So here the standard IO, it's using plus 3.3 volt as the standard one. And here the minimum and maximum voltage level is minus 0.3 volt and plus 0.3 volt. This is for general operating condition. And similarly, we have the 5 volt tolerant. So here we have the plus 5 volt. And here we have the minimum as minus 0.3 volt to represent 0. And we have the maximum plus 5.5 volt to represent logic 1. So logic 0 and logic 1. And the VDD, it can be between 2 volt to 3.6 volt. Okay, just remember logic 0 and logic high. This is the minimum value and this is the maximum value. So if you are somewhere in between, then you are in the floating mode. So the pin is in the floating, it's not in logic high or it's not in the logic low. So at that time you have to bring the pin, either you have to pull up or pull down and bring it to logic low or logic high. So that is the floating mode problem. You can see these details of okay, so if you want to know more about these voltage levels, please go to the data sheet of the corresponding microcontroller. So for example, if you are using this STM32L476, then go to the data sheet of this microcontroller. Just Google this one data sheet and then you will find this data sheet. You will find a lot of information inside. So under section pinouts and pin description, usually there will be a table. Let me just show you now. So I just type datasheet STM32L476. So I get a datasheet of this one. So I can see, because we are using the RG L476 RG. So you can just open this datasheet, download the datasheet. So here you go. So here you will have all the information about the chip, and you just let us find the pin description. I think chapter 4, if I remember. Yeah. So pinouts and pin description. Click this one. So you will have this microcontroller layout. So you will see all the pins, and you will also see a little more detail if you go down in this table. So here you can see the pin type. Is it the input output type, and what is the alternate? It can be used for alternate functions or not, or what kind of alternate function you can use it for. And these are the different version of the microcontrollers. So and for different purposes they are using it for. Okay, and the pin numbers and each version has a different meaning. So if you look into this, you will find little more information about that. So for example, here is the pin name. This is a PF8. So this is the port F and then the pin number 8. And this can be used for IO, GPIO, general purpose input output. And here we can implement these alternate functions into this pin, and additional functions. You can also use this pin for ADC, so analog to digital conversion purpose. So you can always download the data sheet and try to go through that. Okay, so now we will move on further. This is just the schematic of a single pin. So here you can see the CMOS. So here we have the PMOS and we have the NMOS. Okay, let us see here. You can write data to output data register. So this is the write. You are writing the data 0 or 1 into this output data register through this bit set reset registers. And then, okay, you can only write the data into this one. You cannot read the data from here. That is another, you are using another one for the reading the data. Okay, then this data will be transferred to this output data register, that is this one. And then this will be the output of this output data register, or DR, will be given to this output control. Then this output control will give the output to this CMOS, the same whatever the output. For example, if I have 1, then this 1 will be given to both PMOS and NMOS. This is the NMOS and this is a PMOS. Then we know the function, how it works. So 1 will only turn on this NMOS. So it means NMOS will be short circuited. There will be conduction from here to here. So here this 1 will keep this PMOS in off condition. So this is open circuited. There will be no conduction from here to here. This is open. So VDD cannot travel down. So only this VSS will go up, and then this will go here, and then you will get this input output pin status based on this CMOS. So, okay, so in push pull, this is the push pull mode. If you set up this pin in the push pull mode, what will happen? So both PMOS and NMOS control the input output pin. So if you set up, so you see here, there are two possible modes, push pull mode or open drain mode. If you open the microcontroller the IDE, for example, the Cube IDE or Cube MX. I think you did the project. So the first project, you know how to use this STM32 Cube MX or Cube IDE. Cube MX or Cube IDE. So when you set up the pin, you can set up also the push-pull mode or open drain mode for the input pin or output pin. Okay, so in push-pull mode, both PMOS and NMOS can control the pin. So this one will be according to the signal here, this PMOS or NMOS will be turned on or turned off. Then you will get the output here. But in open drain mode, what will happen? We set the don't care condition into the PMOS. So here we keep this PMOS always in the open circuit mode. So that is why we call this an open drain mode. So we are not draining anything. So this is open. And we whenever we get 1, then we turn on this NMOS. If we get 0, then this NMOS is off. We are not doing anything with this PMOS. It means what? It means we are not using this VDD for anything here. Okay, so this is the meaning of open drain mode. Open drain mode means only NMOS control the IO pin. See here, only NMOS control the IO pin. That is called open drain mode because we keep this is open. But push-pull mode means we are using both this transistor and also this transistor. So we are not setting any don't care condition. So we are just applying the input based on the input status. Either of the transistor will be in on, then we will get this VDD and or this ground, and then we get the signal status at the input output pin. Okay, so GPIO modes, push-pull mode. So here you can see again the operation. So when the output control is equal to 0, this is the output control. We get seen already here. You are writing the data, and then the data is coming to the data register, and then going to this output control. So the output control, when it gives 0, then what will happen? This PMOS is on. So this will act like a current source. The NMOS is off. This VDD will go down and it will travel and it will go to this IO pin. If you connect a LED to this pin, IO pin, then what will happen in this kind of situation? So you can connect, for example, you can connect the external LED in the breadboard, or they also had given already the inbuilt LED in the PCB, the microcontroller board you have in your hand now. So here I have connected an LED. So the other end of the LED, of course, it needs a ground to complete the circuit. So I get the high voltage and then I have ground, the circuit is full, so LED is on. So this is a push mode, right? Because PMOS is in the upper push chain. So here this is a push chain and this is a pull chain. So you can call this as a push and pull. That is why we call this is a push pull mode. This is a pushing chain. So it is pushing this VDD down, and this is a pull chain. So this is pulling the ground up. This is why this is called pull chain. So we simply call this as a push pull mode. We are using both transistors. Okay, so now naturally LED is on because the circuit is complete. It has plus and minus. This is one operation. This is for the push mode. Now let us assume this output control has 1 at the output. So this 1 will be applied to both transistors. NMOS is off. Sorry, PMOS is off. NMOS is on. It means it's pulling this ground up, and this ground, this low voltage is traveling up and it's reaching this ground, this IO pin, and this IO pin is connected to the LED and this LED is grounded. So both sides are, we are getting low voltage. So it means negative, both sides of the LED. So LED is off. So of course you can set up some kind of time delay here. So every few seconds once you can give this one, and then for example, here you can set the time delay and you can see this LED will be blinking. So it will be on. For example, if I set the time delay every 3 seconds once, I am enabling this. I am enabling this 0. Then this 0 will turn on this PMOS every 3 seconds once because I set the counter, and then this LED will be blinking every 3 seconds. Okay, so here what we are talking about here, output control is 1 and we apply 1 1 and this ground is traveling here up, and then we have this input pin, input output pin is 0, and we connect to check we get the 0 or not. We are connecting the LED and the LED is still off. So then you can assume here the output control, the output of this block is 1. So this is called pull mode because NMOS is pulling the IO pin towards ground, right? So this, you can also say like this pin is pulling down to the ground, or we are just this pulling this ground to this IO pin. Now naturally LED is off because the circuit is incomplete because we are applying both side negative negative. If you apply both side positive positive, the LED will not on. If you apply both side negative negative, it will not be on. If you apply plus and minus, then the LED will be on. Then the circuit is complete. You know, to have the complete current flow, you need this positive and negative. This is the current flow theory. Okay, so push-pull mode. Again, we see here, when output control is equal to 1, PMOS is off, NMOS is on, VDD is isolated. Now IO pins flows to the ground. This is pull mode. This is what we had seen here. This is pull mode. So here you can see PMOS is off and NMOS is on and VDD is isolated. So because VDD is really isolated, this PMOS is acting as a open source here or open circuit. Then we are doing this. So now this LED is off, right? So now there is another way actually we can do. Even though we get 1, we can keep this LED on. Naturally it's off, but by using small trick we can keep this LED on. How to do that? So instead of connecting this IO pin to LED and then the ground, we are connecting this IO pin to this LED and then VDD. Then the circuit will be completed. For example, here 1 we get at the output, and this 1, because of this 1 there is a short circuit here. This NMOS is on and we are pulling this ground, and then this ground is going the low voltage to this IO pin. Even though IO pin status is 0, we can turn on this LED because okay, this 0 is going to this cathode of this LED, and I connected the anode to the VDD. So it means this circuit is complete. So then this LED will be in on. So it's really up to the circuit designer how we want to implement the function. So whether you get a 0 or 1 at the input, so you can activate this LED on or off. Okay, so either here is the conclusion: PMOS or NMOS is activated based on the value in output data register. This is what you should I want you to remember. So whatever the output comes here from this output control register, we are applying, and then based on this signal value, in either PMOS or NMOS will be on, then we get the signal status at the IO pin. If you want to test this IO pin, yes, you can do so many different ways to test. Okay. Now we had seen so far push-pull mode. We will see now open drain mode. So we can set don't care condition either for PMOS or NMOS. Example, if we set for PMOS, then PMOS is off always, or this is called open the drain, and NMOS is on. So here we have, this is the situation here. So whatever the signal comes out of this register, it doesn't care. This PMOS, we keep it off all the time. Even though you have 0, this PMOS will be off because we set the don't care condition. You remember the mask signal? We have studied this last semester. Mask signal we are setting up. So when you set up the mask signal, then even though you give 0, then this transistor will be off. And this, of course, when you apply 0 here, this will definitely be off. But if you get 1, if you apply 1, then this will be on, then this 0 will travel to this pin. And this LED is connected to VDD, so then it will be on. The same theory. Okay, so this is how you can configure the input pin either in open drain mode or push pull mode. So this is you can see here. You can set up the pin in the either input mode or output mode, and you can go to the clock configuration, and then you can set up the clock speed as the maximum, and then you can go to the configuration tab, and then you can click the GPIO. You can see the pin what you set just before, and then you can see here in this drop down menu you can select either push pull or open drain. So you can set up the output pin in either mode. It's up to you. And then this is the user label. You can give the user label, and of course you can build this. You can build the after that you can just try to create the C code, and then you can edit, and then you can check the output.